Assalamualaikum and hello everyone. I'm Asma. My matrix number is 18752. I'm going to present on lab 4A, which is flow measurement through Venturi meter. Moving on to the objective of this experiment is to determine the coefficient of discharge CD for different Venturi meter. That is the diameter, different diameter. So we can see here is the example of Venturi meter used in this experiment. Next is the setup of the experiments we had carried out. You can see from the diagram, this is the manometer. These are the data that we collect, the Q actual, and then this is the Venturi meter connected between the pipes, and the Venturi meter with the tube is then connected to the manometer, which we will take the reading of the manometer level. And then this one is the buff 1 and buff 2 here. Okay. Next is we can see that the Venturi meter has a converging passage and diverging passage. Okay, the converging passage, the pressure drop while the velocity increase. In diverging passage, it is reverse, pressure increase while velocity decrease. So we can relate to the Bernoulli equation because it uses pressure and velocity while the elevation is the same. So Z is equal, so we can cancel out. Cancel out. Okay. Next is the apparatus as I've shown earlier. The pipeline setup with Venturi meter including the control devices. Next we have collecting tank and stopwatch. The procedure of this experiment is firstly we have to check the clamp and water level, clamp and then the water level of the manometer, water level. Next is we open the gate valve and start the flow to remove the air bubbles from the manometer to the Venturi tube. So from here we have to remove the air bubbles in the tubes. And then wait until the flow is stabilized. And after that, close the gate valve of measuring tank and measure the time discharge. Next, we have to repeat the procedure to get the average reading. Okay. Next, this is the result that we have gotten from the experiment. The actual is given, which we get from the experiment. And then H1 H2 is the reading of the manometer. Reading manometer, reading manometer. And then this column, starting from this and this, is where the formula to get Q theory. And then this one is the Q theory. And this one is the discharge coefficient. As you can see, I faced a few problems in finding the Q theory for this one, this one, because from here the polar is different, so I cannot get. Maybe it's my mistake in the calculation. So how to calculate? I'll show you. Firstly, we have the diameter inlet. Diameter 1 is diameter inlet. So from the diameter inlet, I can calculate the area inlet, which is equal to 0.0063 meters square. and A2 is the diameter outlet. So I get the area outlet which is equal to 0.004 meters square. So this completion is for the first trial. Given also H1 equals to 0.225 meter and H2 equals to 0.198 meter. So firstly, Q theory equals to A outlet times with square root 2G times H1 minus H2, which is the delta H over 1 minus A outlet over A inlet square. Then we just substitute the values 0.004 times with 2 times 9.81 times 0.225 minus 0.198 over 1 minus 0.004 over 0.0063 square. So we'll get the Q theory equals to 3.768 times 10 negative 3 meter cube per second. So let's bring it. And then to get CD equals to Q actual over Q theory. From the tables, we can take Q actual to 0.00017167, and then we divide by 3.768 times 10 negative 3. And we will get the discharge coefficient equals to 0.0456. Actually, from the setup, we will get the Q actual is in liter per minute. So we have to convert it into SI unit. So we will times with 60,000. Then we'll get the meter cube per second. Okay, that's for completion. The discussion is these are from the tables for Q actual and Q theory. We'll get the CD. And from the table, I plot a graph of Q theory against Q actual. What I can say from the results is the discharge coefficient average is equals to 0.01854, which is less than 0.9. 0.9 is the range of CD, normal CD for Venturi meter. So this shows that errors have occurred while conducting the experiment. So during the experiment at tip 6, the air bubbles are not fully removed. Therefore, the manometer is not at the same level when the experiment starts. That is maybe one of the causes that lead to the inaccurate CD. The conclusion is able to calculate the discharge coefficient CD, and the graph of Q theory against Q actual is plotted. Thank you. That's all from me.